All right, welcome everyone. In this explainer, we're going to build a really solid mental model of the central nervous system, the body's main control center. Getting this right is absolutely key for mastering neurology, so let's just dive right in.
So, how are we going to tackle this? We're taking a top-down approach. We'll start at the very highest levels of command and work our way down to the vital highways that connect everything. Ready? Let's get started.
Okay, so our very first stop, we're heading straight to the top. We're talking about the most complex part of the entire system, the brain's command center itself, the cerebral cortex.
So, I want you to think of the cortex as the CEO of your brain. Seriously. This is where the big decisions get made, where strategy is formed. All the complex, high-level thinking that makes us who we are, it's happening right here. It is the ultimate coordinator.
And look at these functions. Every single one of them is directly relevant to what you'll be doing in your careers. Judgment and problem solving, that's your diagnostic reasoning right there. Fine voluntary movements, absolutely crucial for any kind of surgical precision. And sensory discrimination, that's how you'll tell the difference between different types of pain. It all starts in the cortex. All right, now we're going to journey a little deeper into the brain. We're moving past the conscious CEO level to find these critical systems that are running in the background, managing our emotions and our physical actions without us even thinking about it.
And here we have two major players working in parallel. On one side, you've got the limbic system. Think of this as your emotional brain. It's what links how you're feeling to what your body is doing. Like when stress gives you a stomachache, that's the limbic system at work. Then you have the basal ganglia, which is more of a movement modulator. Its job is to make sure all your actions are smooth and controlled.
And this is a perfect example of why understanding the basal ganglia is so important. Because when this movement modulator starts to fail, you see absolutely devastating conditions like Parkinson's disease. Those characteristic tremors, the rigidity, that is a direct result of this system losing its ability to fine-tune and smooth out movement. It's a powerful clinical connection.
Okay, let's keep heading down. Our next stop is the brain's master regulators, the thalamus and the hypothalamus. These two are all about processing incoming information and just keeping the body's internal environment in perfect balance.
So, the thalamus. Picture it like Grand Central Station for your brain. Pretty much every sensory signal, everything you see, hear, and feel, except for smell, fun fact, it all has to pass through here before it gets sent on to the cerebral cortex for the detailed analysis. It's the primary relay center where you first become aware that, hey, something is happening.
Right below the thalamus, you've got the incredibly powerful hypothalamus. And as you can see, it's like a chain of command. It issues orders to the pituitary gland, which then acts like a factory, releasing all these hormones that regulate everything from your growth and metabolism to your stress response. It is a true master controller.
But the hypothalamus's influence goes way beyond that. It's in charge of all those essential, life-sustaining behaviors, what we call vegetative functions. It's the part of your brain that's telling you you're hungry or thirsty or that it's time to sleep. It keeps your body temperature stable and manages your daily rhythms. It's basically the tireless 24/7 manager of your body's entire internal state.
All right, we're on the move again. Now we're heading down into the brainstem area to check out two more really critical systems. One that's all about physical coordination, and another one that's in charge of, consciousness itself.
Okay, so meet the cerebellum. I love this analogy, the maestro of balance. It is constantly getting feedback about where your body is in space, and it's making all these tiny unconscious adjustments to keep you upright and make sure your movements are precise. It's the reason a surgeon can perform a delicate procedure with such grace and control. It's all cerebellum.
Now this next one is interesting. It's not one single structure, but a network woven all through the brainstem. It's called the reticular formation, and you can think of it as the brain's gatekeeper. And just look at how diverse and clinically vital its functions are. It manages your sleep-wake cycle, right? So if it's damaged, you get disorders of consciousness. It also controls vital reflexes like breathing and blood pressure, which is why brainstem injuries are so incredibly critical. It's really like a jack of all trades for your basic survival.
And for our final stop on this tour, we're actually moving out of the brain itself and down into that incredible communication superhighway that connects it all to the body, the spinal cord.
So the spinal cord really has two main jobs. First, it's the main highway for all the motor commands going down and all the sensory information coming up. But, and this is key, it's also the primary center for executing lightning-fast reflexes that are all about protecting you.
And this is exactly how it does it. Just look at this reflex arc. Let's say you touch something dangerously hot. That sensory signal zips straight to the spinal cord, which, without even waiting for the brain, immediately fires off a motor command to pull your hand away. The signal that tells your brain you felt pain, well, that actually arrives after you've already moved. So the really crucial takeaway here is that the spinal cord can act on its own, completely independently, to protect you from harm.
And that brings our tour to a close. You know, from the cortex's high-level strategic planning all the way down to the spinal cord's rapid-fire reflexes, every single component plays a critical, interconnected role. Really understanding these individual parts is the absolute foundation for getting a handle on the health and disease of the entire nervous system.
So, I'll leave you with the final thought, a bit of a clinical puzzle. Based on everything we've just covered, which one of these components do you think would be the most challenging to diagnose if it started to fail, and why? Really think about the subtlety and the complexity of their functions. Thanks so much for joining me on this tour, and as always, keep exploring.